Swayam Prabha. Digital India. Educated India.
Welcome everybody. Today we will be discussing a very important vacuum pump, popularly known as Roots blower, but it is actually a vacuum pump. Originally, historically, Roots has made a Roots compressor type, Roots blower, and he told that it has got maximum volumetric displacement, because he devised in such a way mechanically the lobes with which he made the Roots blower, that maximum volumetric displacement is achieved. But anyway, we will not go into that in detail, but suddenly when you reverse it, instead of blowing air, you can remove also air. So, just what is the difference between a blower and compressor? Blower does not have inlet valve or exhaust valve, it continuously blows from one side to the other side. Compression ratio is not going to be very high for blowers. Okay. It is not like taking some gas molecules, close the valve and bottom dead center, top dead center and close, and after developing a pressure, then you try to put the exhaust valve, then you try to open it and try to maintain some pressures and all this. That is also positively we are displacing air, but like rotary vane pump, we are collecting, sweeping, compressing. But in blower, we are only continuously taking this side, blowing that side. There is a finite compression ratio is there, but it is very small. In rotary pump, for example, 10 power minus 3 to 10 power plus 3 millibar, that is more than 10 power 6, 10 lakh compression ratio. But here 10 power minus 3 to minus 2 or 10 power minus 2 to minus 1, maybe a 10 compression ratio or 20 compression ratio. But this 20 compression ratio is very important, because it is done at a vacuum level where rotary pump cannot handle. 10 power minus 2 it will come, afterwards it stops. Diffusion pump can take over minus 3 onwards, minus 4, minus 5, minus 6. But who does this gap area from minus 1 to minus 2, it is falling, rotary pump, and diffusion pump is trying to pick up from minus 2 to minus 5, like that. Of course, we have to see to that these curves are overlapping, otherwise there will be a pressure range where no pump works. So, you cannot cross over at all. But even if you cross over, both the pumps are coming to a shallow limit. So, pumping capacity in that zone is quite small. Now, if there is a pump exactly at that point, if it has got more pumping speed, that means something is falling, something is picking up with a small overlap, but at that overlap region there is a huge pumping speed. Then there is nothing like that. So, a small compression only from this side to that side, it is not taking all the way to the atmosphere, but it is a very important zone where we require, just like high vacuum to ultra high vacuum, very few parts of very few molecules we are removing, but even then it will create electronics field, it will produce space technology field, like that. So, removing a huge amount of gas is not an important thing, that is okay, that is required initially when you are evacuating, viscous drag and turbulence, laminar flow, all those things, they will be over by 10 power minus 2 torque. So, and you have to do molecular pumps, but in between these two stages the Roots blower comes into picture. With this introduction, we will try to see the contents of this topic. We will see construction of Roots vacuum pump, operating principles, its pumping speed, compression ratios, how it is going to depend on the vacuum pump pumping speed, because whatever I try to give, if somebody is able to take it easily, fully, then I can pump more efficiently. If it is not able to take, then I get choked there. So, my pumping speed in a relay race, it depends on my backing. We will see those concepts as we go ahead, and then we will see finally advantages of roots pumps and certain precautions, and what will be the electrical power rating. Finally, when you design, we will see later in the other lectures, the electrical power should be as small as possible for the same purpose. If you take megawatts of power and try to get some vacuum, it is of no use. So, getting a rotary pump, how much power you are going to invest, how much it is consumption of power. If rotary pump plus roots blower, how much it is going to? Is it worth to having better vacuum with this, or you want more capacity under loading? So, depending on the need of the hour, whether you require more capacity, suppose you require more capacity at 100 torr, forget about roots blower. Sometimes it is required also, because heavy speed if you want, even though it is a viscous region, you may not be able to get full capability of the roots blower, still you may use it, because huge amount of volumetric flow rate. But normally speaking, rotary pumps are much better, watering pumps are better, steam jet ejectors are better to produce 100 torr, 10 torr. You may not require this, but if you want to produce minus 10 power minus 3 torr, after getting the limit of the rotary pump at minus 2 torr, then you have to use it to extend the vacuum, one aspect. Second aspect is, even while it is falling, it can boost it. So, roots blower is going to act like a booster to the rotary pump. So, in many companies they talk booster pump. Actually, roots blower plus rotary pump together is called booster pump. In that combination, it is going to create lot of applications requiring 10 power minus 3 torr, not only vacuum level, but huge capacity at that minus 3 torr. Rotary pump with very high quality rotary pump may be able to do that, but small capacity. Capacity of suction should be very high. At the same time, ultimate vacuum level also should be high, purity. And these two together may also act like a backing pump to the diffusion pump. Just now in the diffusion pump section, that lecture 8 we have seen that. So, that means this booster as a whole is going to have a very good backing to the diffusion pump in metallurgical, very large scale applications, huge chambers of this room size, etc. So, depending on the sizes, levels of vacuum, loading conditions, you may have to decide with booster or without booster. Booster means roots blower, or which combinations, and how much is going to be power saving finally. All this should be dealt by the designer, very important topic by itself. Anyway, coming to the construction, do not worry about the applications, everything in one shot, but later when it comes to the design, etc., we will re-discuss these things. It is just a structure where two 8 shaped lobes are there. They do not touch each other, though it looks very small as if it is touching. Actually, micron gap is there. In fact, gap is not 1 inch almost, and they do not touch the casing also. So, these two 8s, they are rotating in opposite directions. That means, when this 8 comes horizontal, that 8 comes vertical. There is a 90-degree phase shift created by a suitable gear assembly on one side, and on the other side you try to create a motor connected here. You do not require 2 motors, 1 motor. If you put 2 motors, if they rotate in 2 speeds, you are in trouble. They will hit each other and it becomes pieces. So, it should be synchronously rotating at same speed with a 90-degree phase shift. So, if you see here, I have taken this from a company called Everest Vacuum. They manufacture very good roots blowers. You see here, there are where this is connected towards motor side, and the other side is connected to gear side, and in between these lobes are there, and inlet flange, exhaust flange, all that. In literature, you can find lot of drawings and beautiful animations. Intentionally, I am not giving you animations, because here first you listen what is happening. Animations you can always see and understand. These two 8s are rotating in opposite directions. And why it is called blower also I have told, they do not have discharge valve. They move gases by the propelling action, they keep on blowing. Okay. And it contains two counter rotating lobes, they do not touch each other, nor they touch the casing, I have explained you already. And pressure range can be 10 to 10 power minus 3 millibar or even minus 2 to start with a lot of difficulty you can go to minus 3, minus 4. You can also use it at higher pressures, but it may not be always economical, heating effects will come, sound effects will come. There are other pumps which can handle, rotary pump and other things, or watering pumps for food processing at 40 torr, you do not use this. But sometimes you may have to use to boost those pumps. So, while it is acting like a booster for routine medium vacuum pumps, along with the medium vacuum pump and in this booster combination, it also have a very good backing for high vacuum pumps, particularly diffusion pump, etc. But as modern times, the loadings may not be much unless you go to space simulation chambers which are of the building size, etc. Most of the time molecules are very less. You may have only a dry pump backing the turbomolecular pump, etc. or several such parallel stages of pumps you can connect to evacuate. There are many other versions, but you have to see the cost economics, they are very costly pumps, whereas a diffusion pump with a roots blower and rotary pump is very cheap. So, you have to decide which application and what is the power level requirement and whether reliability level or technology upgradation possibilities, etc. So, pressure range is decided like that, and it is basically a dry pump because they are not touching each other. So, no lubrication is required, no wear and tear, they do not touch any casing, no heating effects apart from little bit of heat of compression. But since we are handling in vacuum side, the number density is less, the heating effects are also not much. If it is there, we need to take care of how to do that. It is in system design when multiple roots blowers are connected in series, that is a technology by itself. We will again rediscuss these things when we go for pharmaceutical applications and food processing applications, where several boosters are connected in series along with a watering pump or a steam jet ejector, etc., etc. Why this, why not that, like that? There are selection criteria. It cannot be explained in a small time. We will take an application and force these pumps there. Why this pump, why not that pump? And this pump is a very famous pump. Many companies in India as well as abroad manufacture. Very high quality precision machining is required. Bearings on both sides and your gear assembly, synchronous gears. It is a technology by itself. And having some external cooling issues like chambers, all that if you look at internet, you will get beautiful drawings. Okay. So, it boosts the backing rotary pump, and along with that it may also act like a good backing to a high vacuum pump. They are available in various ranges from few meter cube per hour to a 1000 meter cube per hour. Meter cube per hour is also pumping speed unit. Sometimes I use meter cube per hour, sometimes I put lot liters per minute, 300 liters per minute. That is a typical thing that is used by rotary pumps because it is small scale. But when you go for large scales, meter cube per hour type of thing is another unit. Whatever it is, volumetric displacement. So, this is a little bit of constructional introduction about roots vacuum blower. Let us see operating principles. Those who have got little bit of logic and engineering brain, they can easily understand. These are various locations of two counter rotating 8 shaped lobes. If I show the animation, that is a different thing, but I do not intend to do it. I want to teach exactly what is going on here. So, this is one instant of time. As the rotation progresses, you will come to this stage further here. So, a stage will come where gas is drawn and gas is distributed like that, and it starts rotating in opposite direction. This rotates in clockwise, this rotates in anti-clockwise. A situation will come. So, a part of the volume here is trapped. Of course, there is a small opening, but since it has already been evacuated by a backing pump, the gap is so small, it is smaller compared to the mean free path. So, molecules here may not be able to go to that side. It is like you are a hefty person and door is open, but it is open small amount of open. Even if it is open, you cannot go. Namesake it is open. So, the vacuum level is fairly high. At that time, my free molecular distance is so high, I will be freely moving. Unless there is a finite chance statistically to enter into that gap, I may not feel that other side pressure. So, leaking into high pressure to low pressure, relatively high pressure to low pressure will not take place because it is a molecular flow, it is not a gas flow. Gas flow will be assisted by the viscous drag, they are not there. It is acting like a booster pump of an already evacuated atmosphere of -1 torr or 1 torr by another water ring pump or rotary pump, etc. So, that you have to take into account. So, this is how various rotor positions are there. In rotor position 1 and 2, for example, the volume of the intake is increased, you can see. While it is increasing for the same number of moles, so more suction will take place from the vacuum side, which is connected to the chamber, or it is connected to another high vacuum pump depending on the situation. And the further rotation will create 2, 3 situation. By 3 situation, some number of molecules which were there in the system, they are entering because of the volumetric increase here and then slowly get isolated. That means, this many molecules are permanently removed from the chamber. Now, at that time, this trapped volume, this situation will come 2 for this lobe, 2 for this lobe. So, totally 4 times this much volume compared to the rotational speed will be the volumetric displacement, ideal volumetric displacement of that. If there is a constant pressure maintained under constant loadings, etc., that much of volumetric units it can handle. This is an ideal expression 4 into V into N, but it is not going to happen, it will be slightly less, because even if it wants to come out, the backing pump should be able to remove fast. Suppose it is not able to remove, while it is opening, that high pressure side will again go back. So, while again the next time the same lobe may force earlier trapped volume plus these molecules which have come back. So, a net effect will be slightly less. That means, there is a reverse flow taking place at some instant of time. Just it is opened and pressure is higher this side by virtue of backing pressure, and that may drive the molecules, because backing pump is not busily, it is unable to take all the molecules. Some molecules at that pressure already small opening is there, it may go back. So, all these things together will create a pumping action finally, and this much type volume multiplied by 4 into N is only theoretical maximum, but depending on the backing pumping capability, the front side pumping capability of this roots blower changes. So, displacement is originally 4 Vn, but the actual pumping speed will be slightly less than the theoretical displacement. Sd is different, S is different. S is the realistic pumping speed in engineering units of meter cube per hour, but Sd is the displacement volumetric units purely in terms of number of rotations and volume that is being trapped. Okay, ideal situations. So, this is what I have explained here. That means, sort of compression is going on, but not because of any volumetric decrease or something like that. It has collected and it is pushing towards the high pressure while isolating a gas volume. So, it is sort of low pressure it collected, kept it, high pressure it is throwing. So, it is able to withstand these pressure drops. That means, there is a compression going on in spite of forward blow of the molecules. So, that is how roots pump works in a range where the mean free path is longer compared to the gap. That situation has to be maintained. Otherwise, if you try to compress through this gap, it is again leaking back, then very small compression ratios can be created. So, more the vacuum level, less the pressure, the ratio of the pressure here to here will be different. So, compression ratio depends on the pressure existing here. If the already a good vacuum conditions are there, then molecular flow conditions will be there, compression ratio will be more. If bad vacuum, start vacuum, only atmospheric pressure, then even if you are trying to take it out, this may again go back, because gaps are few, not 1 inch, whereas mean free path is in microns. So, it will be acting like a gas flow back because of pressure drop driven. All those concepts, if you want to understand thoroughly, You have to go through the Wikipedia, there are pages, more than 10-20 pages are written on this, and roots blower there are books also. It is an industrial pump, very important pump, and because there is no touching point, it will rotate at 3000 rpm. High pumping speed basically it is creating when rotary pump is falling. That means it is boosting its pumping. It is extending its vacuum level, but we are not bothered, some applications we are not bothered about -3, -1 torque, we wanted to extend, we want to enhance, boost the pumping speed. So, you please read out all these things. So, having understood the working principle of roots blower and its ideal maximum displacement, etc., in the practical situation, the pumping speed is a function of the pumping speed of backing pump and the theoretical compression ratio of a roots blower. Here I have given few curves. The compression ratio is defined as outlet pressure of the roots blower to the inlet pressure. Pressure means vacuum levels. Backing side there is a rotary pump or some other pump is connected. Front side the chamber is connected. So, depending on this capability of the backing pumping speed at that pressure of P naught, that is SB, and depending on the maximum displacement which you have told 4 times V times N of roots blower, which is independent of pressure, that is the maximum displacement. But how do this PA is taken care? Because of a factor called K, that K depends on P naught by PA. So, PA is the inlet pressure of the chamber being evacuated along with this booster connected to a rotary pump. So, this P naught by PA, if you plot it as a function of the outlet pressure, you will get a peak like this, which is peaking around 1 millibar. But either side it will fall. Why? Because on high pressure side, if you try to displace the molecules and try to put it here, because of high pressure there will be forcing the molecules. That way backflow is there. So, front flow minus backflow, that way it will be affecting the compression ratios. So, finally, these effects are to be seen as a combination of several effects: backing pumping speed, actual displacement and the compression ratio, which is a theoretical aspect that depends on the gap for the backflow, as well as sometimes the adsorption on this vacuum side and they get desorbed again. These effects also play an important role. So, several physical effects are creating a compression ratio dependence as a function of pressure. You do not have to follow totally in detail about fundamental physics at molecular level, but it is enough if you understand the compression ratio is a function of the output pressure, which is in turn depends on the capability of backing pump. So, if you know the pumping speed and if you, of the backing pump, and if you know the compression ratio, you can work out at any instant of time what will be the pumping speed of the combination of the roots blower and the rotary pump. They together, this is called booster pump. What will be its pumping speed? That can be plotted, and that equation I am not giving you here. This equation is plotted here, and you will see speed of the combination as a function of inlet pressure. So, a designer has to think what type of backing pump I have to use and what will be the compression ratio at which I am working. Suppose I am working for pharmaceutical applications, I will be somewhere here. If I am working in very high vacuum applications, molecular distillation, and I do not want to use diffusion pump, I will be working at -3 torque, I will be doing this. So, at that stage what is happening to the backing pumps? All the decisions you have to take, of course, keeping cost economics in point and quality requirement. So, depending on the backing pump requirement and the combination pumping speed, there will be a compression ratio. So, backing pressure and the pumping speed of the backing pump and the combination will adjust automatically to maintain the continuity of the mass flow automatically because of the fundamentals, and you will get various pumping speeds at various pressures. Well, it is little mathematical and it is involved in engineering, and it is not even computational fluid dynamics, it is a computational molecular dynamics. Statistical things into come into picture and various other geometrical parameters come into picture. So, there are some standard equations. So, you need to take the pumping speed versus pressure curve of the backing pump from the manufacturer and the compression ratio which is universal for any roots blower, and take care of that and try to calculate the effective pumping speed. With that, are you getting boosting action, is it good enough for your application, you decide and go ahead. So, these curves will help us to design the pumping system. Okay. So, with this idea of construction and action and design aspects of roots blower, we will come back to this when we are discussing it in pharmaceutical applications again. Okay. So, let us conclude our things by talking advantages of roots pump, and little bit of disadvantage will be always there. It is a costly thing, but it is giving a boosting action, and the electrical power requirement is not much, because even though it looks like a costly cheese, one time you are trying to invest, but afterwards power requirement is not much. So, the main advantage of roots pump is their ability to handle large gas loads in a pressure region. I told you in the beginning, neither rotary pump has got a high pumping speed, nor a diffusion pump has started getting a high pumping speed. In that region, luckily this roots blower has fallen. So, initially roots has never decided that it is going to work like a pump, but it has given lot of economic benefits, and roots blower, since it is only reversal, people are still using on with his name roots blower. Initially roots has never thought that it is going to be working in a technological applications for involving high vacuum or ultra high vacuum. So, it sometimes you will get offshot of that. This is an advantage. Okay. So, it is also used as a backing pump with a boosted capability in the diffusion pump, but very little power consumption because of lack of wear and tear, that we will see later. And it also avoids migration of impurities from the backing pumping side to the process side. This chemical contamination is not allowed in IC chip manufacturing, etc. Right from the history of evacuation from atmosphere of an IC chip chamber is very important. So, you have to involve dry pumping technology, which we will see in the next class, right from atmosphere. So, sometimes rotary pump may not be allowed, but even if it is allowed, if you add this roots blower, then it will reduce contamination quite a bit. So, several pumping combinations are available with several ultimate vacuum pumps and several effective pumping speeds of the booster pump. When we say booster pump, it is a combination of roots blower plus a backing pump. It can be rotary or water ring pump or anything else, dry pumps or screw pump, anything. It boosts. That way, the roots blower is common to all the pumps like rotary pump, dry membrane pump, screw pump, scroll pump or water ring pump. All those pumps can be boosted with the roots blower if you require additional vacuum and also additional capability to pump more, and with a reduction in the power consumption. So, there are so many advantages. Let us see finally, this is the last slide where finally money matters. If you only one rotary pump you are able to get -2 torr, why unnecessarily put another booster? No. If you want to get huge pumping speed at that particular pressure, though rotary pump is able to create that vacuum after 10 hours because it is a low pumping speed, but I want it in 1 hour. So, I want higher pumping speed. Then what happens? Then you have to have the booster, but booster one time purchase high rate, but afterwards electrically the total power consumed by the roots blower plus rotary pump of a smaller capacity, because roots blower is there, I do not need a bigger capacity rotary pump. So, total electrical power of roots blower and rotary pump is less compared to an equivalent only big rotary pump that is to be used to get that type of pumping speed at that pressure. So, you are getting two advantages. One is effective pumping speed is high and power rating is less. Third advantage is with this combination you get a better vacuum level. So, with one purchase you are getting three advantages: enhanced pumping speed and chemical quality is also better and improved vacuum level. The third is most important, which is connected to the fund, which is connected to the finance, that is electrical power requirement is going to be less. Let us understand this by an example. I have taken this example from the Everest blowers vacuum roots blower combination with a rotary pump, because they are regularly producing these blowers for pharmaceutical and various other applications. They also give it as a backing pump for various industries in diffusion pump based. There are several other companies also in India and abroad who are producing different qualities of roots blower. Let us take the example from this. They have a super vane 400 booster pump. It is nothing but a combination of a roots blower and the rotary pump. Its effective pumping speed at the peak level is 400 meter cube per hour. And if you are operating by chance, that is the working pressure of any process application like a chemical or pharmaceutical, you are getting 400 meter cube per hour with two pumps and with a vacuum level of 0.5 tar, but power consumption is only 5.7 kilowatts. Same thing if you want to do only one rotary pump, you may be able to do it, but you have to add 11 kilowatts of power. That time roots blower is not there. Much higher capacity than what is required, you have to use it. Higher capacity rotary pump without helping hand of roots blower means higher rating of the motor, and even with all that it produces 0.5 tar only. So, vacuum level has improved by 10 times, power is reduced and chemically also it is purer. So, everything is having advantage by using roots blower as a booster combination. So, power ratings and precautions that to be taken while designing, whether it is necessary or not. Suppose you are going for 100 tar or 200 tar, 300 tar, that time it may not be required. So, depending on the application, you have to choose whether you require a booster or not. Thank you very much.